Hello everybody, my name is Joshua Kilola, and today we're going to be graphing the logarithmic function of f of x equals log to the base of 3 times x plus 3. We're going to move over to the scrap sheet of paper right here, and to first start solving this problem, I want to try and find my points on the graph, and to do that, we're simply going to be looking for x. So let me write down basic variables for the y. And how will we find this x? Well, now that we see we have the base of 3, we're simply going to square root that 3 times, 3 to the square root of 2 minus 3, because this plus is opposite since we're moving along the x-axis. So the start is going to be 3 squared minus 3, and 3 squared is 9, and 9 minus 3 would be 6. Next, it's going to be 3 squared to the third minus 3, and 3 squared to the third is 27, minus 3 is 24. And so on, we're going to do 3 to the square root of 4 minus 3. That'll give us 81, and 81 minus 3 is 78. Now that we know our points on the graph, we're simply going to plot it. And since this seems to be an incline because we keep going up in numbers, we know our chart or our graph is going to go on an incline. So to start, the y-axis will be 0, 1. So we know this is going to be our y-intercept, and we know our graph needs to pass through this point. And let's just say this next point is 6, this next point is 24, and this next point is 78. Now that we know where our graph is passing through, we're simply going to need to graph the logarithmic function on an incline like this, and that's how I got my answer. Next, we're going to be looking for the asymptom. And to find the asymptom, we're simply going to look for the vertical axis. And that's given to us already. The vertical axis will be -3, because we know the graph is shifting along the opposite way of x plus 3, which will be left 3, which will be -3. So we know the asymptote, I don't know if I said that right, vertical asymptote is -3. Now, we're going to be looking for the domain and the range. And to find the domain, we're simply going to solve x plus 3. So x plus 3 is greater than 0. Or another way you could write it is, actually no, that's correct. You're going to subtract the 3 to single out the variable of x. And that's going to give us x is greater than -3. So now that we know that x is greater than -3, we can just graph the function, put it as -3, comma, infinity, because x is greater than 3 and 3 is not greater than x. So that will give us our domain. And for our range, I believe it would just be the y-intercept. The range would be infinity, comma, infinity. Because we're going from negative to a positive, and that seems correct. Now that we got all our solutions on our first problem, let's move over to our second problem. Our second problem is log times y squared x over 10 to the square times z. Now, since we know that log is breaking down into each of these expressions, we're simply going to separate these variables. So we're going to start with log times y. Don't forget to put your parentheses with the square of x minus, because since this is y over 10 squared, we know there's a minus sign, minus log times 10 squared times z. And now we're just going to simply try and break it down even more. And since we know that log and 10 equals 1, we're simply going to log times 10 equals 1, so we're simply going to distribute the 2. And doing that, we get... Actually, no, I'm wrong. Let's break down this even more. So now we're just going to break it down even more. So we'll have log y. Let me come down here. Log y. Correct. And since the square root of x is simply x to the 1/2, we know it's going to be 1/2 log. Oh, keep breaking my pencil. 1/2 log times x minus log. Okay, now we're getting to this side. So now that we see that log times 10 is simply 1, and we still have a remainder of a square here, we're just gonna, if I'm correct, we're just gonna cancel out this square through multiplying it times no. We're simply just going to cancel out this log right here. So that just leaves us with minus 2 times log times z. Don't forget your minus sign. And I believe that is the correct breakdown of the function. But just to make it look even better, it's just going to be log times y plus 1/2 log times x minus log times z minus 2. And that would be the solution for our second problem. Now moving on to the third problem, we said log to the base of 2 times 3x plus 3 minus log to the base of 2 times 2 equals log to the base of 2 times x plus log to the base of 2 times x minus 1. Now, we're simply just going to compress this fraction so all these numbers don't just clog up. And so to do that, we see that there's a minus sign right here. So we know that this is a fraction of these two. So this would be log to base of 2 times 3x plus 3 divided by 2. We won't need to write the log twice since it's just going to distribute to both of these fractions. Equals log. Okay, that's a 2. I got confused by my own handwriting. Log to the 2 times x times x minus 1. And now that we have our condensed logarithmic function, we're simply just going to break it down even further and distribute. So distributing from the left to the right, actually, we're going to get rid of our log, which will just leave us. They'll cancel out each other. And we'll just be multiplying both of these sides by the remainder of the 2. So 3x plus 3 over 2 times 2 will simply just cancel out this 2 right here. So that leaves us with 3x plus 3 equals, now to come over to this side, we know that 2 times first, let's distribute everything inside. So that leaves us with x squared minus x. Then we're going to bring our multiplication in. So that leaves us with 2x minus 2x squared minus 2x. And so now we're simply going to subtract to get all our equations on one side. So this would be minus 2x squared minus 2x. And this will leave us with negative 2x squared. Oh, this would be plus 2x. Plus 5x plus 3 equals 0. Now we can see that this looks like a quadratic equation. So now we're just finna factor out everything in this equation. And factoring this out, we get, I believe, 2x plus 1 and x minus 3. Now, you could just simply check to make sure that you factor it out right. 2x times x is 2x squared. Oh, I did something wrong. I forgot. I forgot to change this symbol to negative. So 2x squared. Yes, I'm just checking. 2x squared, 2x times x equals 2x squared. Let me get rid of this negative. Plus 2x times 3, which will be 5x. And 1 times negative 3. See, that's why we always gotta check. Always gotta check. 2x minus 3. Yes. And then we'll simply equal this to 0. And how would we get all these problems and x singled out? We'd simply subtract. No. Yes, this should be a plus 1. Should be a minus 3. Let me recheck my formation. Since we multiply this by 2, it should be a negative 3. Okay. So wait, I confused myself. multiply this side by 2, that cancel out. Multiply that side by 2, that cancel out. Then that'd be 2x. Minus, get this on one side, be negative 2x. Oh, okay. No. So this would be negative 2x squared plus, this would be negative 2x. So this wouldn't be a negative at all. And this would be 2x squared minus 2x. Put that over the other side, that'd be negative 2x. So negative 2x would be negative 2. Negative 2. Okay, there we go. So I rewrote it wrong. That's my bad. So now to simplify this, it would be, we'll bring it down to negative 2x plus 1 equals 0, and x minus 3 equals 0. Plus 3 plus 3, so this would be x equals 3, and this one would be minus 1, x. So this would give us negative 1 divided by negative 2, which will be x equals 1/2. And to figure out which one is a solution to the logarithmic equation, we know that x equals 3 will be a solution, since it's a whole number, I believe. Yes, and that will be how we solve it. So our final answer will be x equals 3. Thank you. Have a blessed day.